Welcome to section 3.1, the constant E and continuous compound interest. Our goal is to work with the constant E and solve continuous compound problems. So the number E can be represented by the limit as n goes to infinity of 1 plus 1 over n to the nth power, or the limit as s goes to 0 of 1 plus s raised to 1 over s power. Our theorem that we'll be using today is continuous compound interest. The formula for that is A equals P times E to the RT. I call that the PERT formula. P represents our principal that we have invested. R represents our rate expressed in decimal form. And the idea of being compounded continuously is if it were compounded in an infinite amount of times. A represents the amount after t years. So t is our time given in years. After we calculate however long our amount has been in there, compounding continuously, A is the amount it will be. Let's take a look at our first one. Use a calculator to evaluate A to the nearest cent. A equals 700 E to the 0.05 t. T is going to be at 3 years, 6 years, and 9 years. So let's start with t equals 3. What we'll do is we'll plug in a 3 where we see the t. A equals 700 E to the 0.05 times 3. This will give us 700 E to the 0.15. E raised to the 0.15 is about 1.16183. And so if we multiply those, we get 813 and 28 cents. Next, let's do t equals 6. A equals 700 E to the 0.05 times 6. We'll have 700 E raised to 0.3. E to the 0.3 is about 1.34986. Multiplying those gives us 944 and 90 cents. And t equals 9. A equals 700 E to the 0.05 times 9. 700 E to the 0.45. E to the 0.45 is about 1.56831. And multiplying those will give us 1,097 and 82 cents. And so, obviously, the longer you invest, the better it is. Number 2, solve for t to 2 decimal places. 4 equals E to the 0.07 t. So now we're going to use those log properties that we learned about earlier and get our t alone. Since we have a base of E in this problem, we will use natural log. So I'll take the natural log of both sides. We'll take natural log of 4, natural log of E to the 0.07 t. The natural log and E are inverses, so those will cancel. So we're left with natural log 4 equals 0.07 times t. Now it's a simple division. Divide by 0.07 on both sides. T equals the natural log of 4 over 0.07, which will give us 19.80. So what this tells us is we'll be able to invest $1 basically, and the amount of time it will take at 7% is going to be 19 years to get to $4. I guess if we were going to put it into context. Anyway, number 3, solve for r to 2 decimal places. This time we're looking for a rate. Same idea, we want to find r, so we will use our log properties. Since it's a base of e again, we'll use a natural log. So we'll take a natural log of both sides. Those are inverses of each other. So we have natural log of 7 equals 3 times r. Dividing, we get r equals the natural log of 7 divided by 3, which is 0.6486. That tells us the rate would be 67.86%. Bank A offers a 3-year CD that earns 2.05% compounded continuously. If $5,000 is invested in the CD, how much will it be worth in 3 years? Oh, there goes a typo. So, since it's compounded continuously, we are using the PERT formula. We are told we invested $5,000, so that is going to be our principal. We are told the rate is 2.05%, but we move the decimal to put it in decimal notation, so we have 0.0205, and it's been in there for 3 years. So 5,000 times e raised to the 0.0615. E raised to 0.0615 is about 1.06343, and multiplying that out gives 5,317.15 So we can write the account will be worth $5,317.15 in 3 years. How long will it take for the account to be worth $10,000? So now we want the ending amount. Well, we're given the ending amount. $10,000 when we invested $5,000, same rate, 0.0205, but we don't know how many years. So we're leaving a T for our time. Let's divide that 5,000. So we have 2 equals e to the 0.0205 times t. Basically, we're looking at when is it going to double. What's the doubling time? Since we have a base of e, we'll take the natural log of both sides. Those are inverses, so we have natural log of 2 equals 0.0205 times t. Divide. T gives us 33.81. So it will take about 33.81 years to double in value. A bond will be worth $25,000 at maturity 10 years from now. How much should you be willing to pay for the bond now if money is worth 2.6% compounded continuously? So we hear the word compounded continuously, or the phrase, I guess. We know we're using the PERT formula. In 10 years from now, it'll be $25,000, and they want to know how much we will invest now. So that means we're looking for a principal in order to reach $25,000 as our final amount. The rate being 2.6%, we're going to convert that into decimal, so 0.026, and it says 10 years from now, so if we leave it for 10. If we multiply those, we'll have P times E to the 0.26. And if we divide by that, so principal is about $19,276.29. So you should be willing to invest $19,276.29 today. Okay. A woman invests $15,000. Okay, so now typo. In an account that pays 2.9% compounded continuously. If the woman needs $20,000, there are so many typos. $20,000. How long will it take to accumulate that much money? Okay. We read compounded continuously, which tells us we're using the PERT formula. She wants to end with $20,000, so that's our amount. And she's investing $15,000. The rate is 2.9%. In decimal, we have 0.029. How long will it take? That's T. We want to know the time. So let's get T alone. Divide by 15,000. So we have 4/3 reduced equals E to the 0.029 times T. We have a base of E, so we'll take the natural log of both sides. Those are inverses. So we have natural log of 4/3 equals 0.029 T. We divide. T is the natural log of 4/3 over 0.029, which is 7.57. So we can say it will take about 7.57 years for the woman to have the money she needs. And that is our last one for today.